Chapter 15, Sound. We have been talking about waves and the way in which waves interact with medium and without medium. And we've been talking about electromagnetic and mechanical wave. And what we are going to start chapter 15 on is mechanical waves. Sound is a mechanical wave. It needs a medium to go through. Chapter 16, we will talk about an electromagnetic wave, such as light. So sound in 15, light in 16. What is sound? Sound is a pressure variation, so it's a change in pressure throughout the medium or throughout the air. And this change in pressure is going to cause vibrating and regular oscillations in air pressure. One thing that drives me nuts, especially when I talk to 8th and 9th graders, is the idea of what travels faster, speed or light? Or sound or light? Which one travels faster? Sound only travels at about 770 miles an hour, depending on the temperature of the atmosphere through air. Travels a little faster in water, but only 770 miles per hour. Light travels 180,000 miles per second. Don't ever tell me that sound travels faster than light. So you have there for every increase into 1 degree Celsius, sound travels about 0.6 meters per second faster. Echoes, all an echo is it's a reflected sound wave. They can be used to calculate distance between objects. We use this with sonar. Sound waves echo. We know how fast sound should travel based on the temperature, based on the substance or the medium it's traveling through. If it hits something and bounces back, we divide that time in half, and that'll tell us about how far away that object is. That's how the Navy scans the ocean floor. It's how they use radar in the ocean for submarines and everything like that. So that's kind of an example of the use of how sound is used. Sound, unfortunately, not everybody has the ability to hear. So what kind of goes wrong? How does the ear work? What's the mechanical process of the ear? Well, tomorrow in class, we'll play a video that'll test your frequency, kind of depending on how well you can hear, what frequencies you hear at. Typically, the older you get, the less frequencies you can hear. So a newborn baby is going to have that full 20 to 20,000 hertz range, whereas someone your guys' age is going to be about the 20 to 16,000 hertz range. Someone my age will be about the 20 to 15,000 range. And someone a little older, such as like Mr. and Mrs. Peterson, will be somewhere in that 20 to 11 or 12,000 hertz range. So it's kind of crazy how the ear over time does get worn down and becomes less sensitive to sound. But how does the ear work? There are 3 parts to the ear. You have the outer ear, the middle ear, and the inner ear. The outer ear is the pinna. That's essentially the visible part of the ear. That is what's collecting sound. You kind of pretending to be a big cup. That sound then travels through your auditory canal. That's kind of hopefully what you don't put a Q-tip down if you're cleaning your ears. And then it's the end of the outer ear is the eardrum, which is a small flap of skin which helps figure out or feel pressure sensations. The middle ear consists of 3 tiny bones, the hammer, stirrup, and anvil, which are transferring those pressure sensations detected by the eardrum. And then the oval window is vibrated by those bones and through watery fluid. And the cochlea, it produces sound. The cochlea is a spiral-shaped object in your inner ear with tiny hairs, and it transmits at pressure variations into the nerve cells in your ear, which transfer that to the brain. So it's kind of a very intricate process. In fact, people who are deaf can have cochlear implants. A lot of times that's the missing piece in this puzzle is a cochlea, and they can have their cochleas transplanted, and people can hear for the very first time. So kind of neat. But outer ear, middle ear, inner ear, 3 components of the ear. As I mentioned earlier, humans typically can hear anywhere from 20 to 20,000 hertz. The older you get, the less that range is. 8,000 hertz in sensitivity is usually the limit for older adults. They used to have cell phone rings. They still do have cell phone rings with very lower, higher frequencies in which adults can hear, but kids can. So we'll kind of test around with your ability to hear tomorrow and what range of frequencies. When you do hear, how you perceive sound. You perceive sound in two ways, really, pitch and loudness. Pitch, is it high pitched or low pitched? Pitch is how you perceive sound. So it's a high pitch or a low pitch. Pitch is how you perceive sound. From a scientific perspective, it's the frequency of vibration. Loudness depends on the amplitude of the sound wave. That's key there. Loudness depends on the amplitude of the sound wave. Not the wavelength, not the frequency, but the amplitude of the sound wave. Loudness, the ear can detect up to or as small as 2.0 times 10 to the 5th pascals in a pressure change. 20 pascals of pressure on the ear cause pain. Your eardrum is pressurized. So if you blow an eardrum, there's too much pressure, it's going to be an extremely painful process. Sound level is measured of the amplitude of the wave again, and it's measured in decibels. Sounds over 100 decibels can cause permanent damage. So if we take a look at our decibel scale, 130 is your typical threshold of pain. What's neat is there's a lot of cell phone apps which are decibel meters and will measure the decibels. Anyone want to guess the typical 8th grade hallway out here, if I took a measurement in between hours, what the decibel level would be in the 8th grade hallway? It'd be anywhere, last year it ranged anywhere from 91 to 97 decibels during passing time. Now if you look at that chart, that's somewhere between a semi-truck and a jackhammer. So it's no wonder that teachers will not be able to hear by the time they retire after being exposed to so much noise. In fact, if you kind of look at this, I mean, 20 is a quiet rural setting, or 30 is, 20 is a whisper. Most of your life is probably around 50 to 80 decibels. You have to be careful though, because once you lose your hearing, you can't get it back. There's something called noise-induced hearing loss, which is kind of a new fad with younger people, and what's happening is they're noticing they're losing their hearing much faster than anybody else. And it's due to just listening to too loud of noises over an extended period of time, whether it's in your Beats or headphones or your buds for your iPhone or iPod, whatever it is. You got to be careful with the volume of that. So just a little FYI there. Last thing when we talk about sound, and pitch is how you perceive sound. The Doppler effect is the shift of sound created when it's moving. So when something is moving, it's going to change the frequency at which you hear it. When something is moving towards you, it's going to sound higher pitched. This is the Doppler effect. The reason it's going to have a higher pitch is because the waves are bunched together. So if we see the Doppler effect, we have an ambulance coming at us. See how the waves get bunched really close together here? You're hearing more waves. It's going to create a higher pitch. The second that ambulance passes you and starts going away from you, what's going to happen is those waves are going to get farther apart. When they get farther apart, you're going to hear a low pitch. What's a classic example? I don't know if any of you watch NASCAR, but if you ever watch NASCAR and they put the camera down when all the cars are coming by, it sounds like just like that. That's the Doppler effect. Think of it. What happens when the car is coming towards you? You get that high, and then the second it passes, it's lower pitch. So when we talk about sound, when it's moving, when an object is moving towards you, it's a higher pitch. When it's moving away from you, it's a lower pitch. That's Doppler effect, waves shifting when the source is moving. And we'll talk about this with light too. It can change the color of light over time. But that's 15.1. We'll play the frequency video in class tomorrow and do a couple other things with sound in class tomorrow. Good night.